All right. Welcome everyone to my short presentation of a FHIR-based document registry for managing large-scale digitization data. A quick couple of words about me. My name is Simone Heckmann. I'm consulting with a company that's called DMI in Germany that is specialized on digitizing paper-based patient records. And I'm also CTO of Gefyra, which is a small company that offers FHIR training and consultancy around Germany. A quick couple of words about what DMI does. It's called Deutsches Mikrofilm-Institut, which means it's digitizing paper, basically. That's the core business of this company. So the important factor is to have auditable document archiving solutions. And they've been doing that for many, many years. So far we have more than 400 customers in Germany, mostly from the healthcare sector. And there are more than 1,000 people working for that company. We are scanning, digitizing more than 36,000 pages of paper every day. And that amounts to more than 500 million documents per year. So these documents get scanned and digitally archived. They have to be signed so that they are audible, that we can prove that these documents have been archived in an unaltered state. And we do that in 3 redundant data centers across Germany. So what we are now attempting, in the past years, basically the business has been scanning the documents, archiving them, and that was basically it. There wasn't really much happening with the data right there, but at some point you realize that there's so much more that we could do than just storing away these medical documents. And that's how the new product, which we call AWS 4.0, came into being. And this is basically about, having a meaningful way to deal with these documents and make them reusable and retrievable. So the question is, the questions we want to be able to answer is, for example, a very simple one, which already we were able to tell, is just where are all the documents archived for one specific patient. And that is considering that the patient may have multiple encounters, so there may be multiple records that we digitized, and the patient may have been in different hospitals that are all customers of our company. So the next questions that we wanted to solve is, for example, which kind of documents are the most prevalent? Because during our digitization process, we have algorithms that are trying to determine what kind of document it is that we are scanning right now. And these algorithms have become pretty reliable, so we are able to tell for each and every document that we digitize what kind of a clinical document it is. And now, of course, we want to be able to have like the bigger picture of how often do certain documents appear in one specific customer or across all customers. So another thing that we would like to be able to do is to check whether patient records are complete. In many cases, there are mandatory documents that have to be present for each and every file, like patient consent, for example. So that is something that we want to be able to determine. Then, of course, we could be more granular about that. Like, for example, if there has been a surgery for a patient, an invasive surgery, we know that there also has to be a surgery protocol or an anesthesia document. So, and beyond that, we are also currently working on solutions to not only differentiate different types of documents, but also to mine the contents of the documents for structured data, like diagnosis codes, procedure codes, etc. And that again would help us to be able to answer questions like which documents for a specific patient mention, for example, a diagnosis of diabetes. So in order to build a system that would enable us to answer all of these questions, we had to find a technological basis, and we decided to do this with FHIR. And the reason why we decided to use FHIR was that, first of all, it was important for us to be compliant with IHE, because IHE standards are the de facto standards for document exchange. And since we also want to be able to exchange documents, IHE, specifically the XDS protocol, would be the way to go. However, with XDS, we wouldn't be able to answer all of the questions that we have. That would only be able to handle document metadata. But we wanted more than that. So we looked at the new version of IHE document exchange, which is called the MHD profile, which is basically doing the same, but it's based on FHIR. And with that, it gives us a lot more ways to expand our original system. Then again, FHIR gives us the opportunity. There are so many FHIR-based servers around that store FHIR resources natively that we could easily opt for any one of those solutions and at the same time have a vendor-neutral archive. Because the FHIR resources are stored natively in the database, we can simply just export them and store them into another FHIR-based database if we want to change the system for some reason. Then again, we have the need to integrate unstructured documents, basically just PDFs that are the result of what we scan, with structured data. For example, diagnosis codes that we extracted from the contents, or information that we got from other sources that give us more context of the patient record, like what was the main diagnosis for this case, or why was the patient admitted to hospital in the first place. Of course, we are very happy that FHIR also gives us abilities to integrate terminology services, because that's an important part of our implementation. We are absolutely depending on the data validation abilities that FHIR gives us to make sure that everything we put into our document registry is valid and complete and has the proper terminologies. We need scalability because, as I said earlier, we are dealing with about 500 million documents per year. We need extensibility because there's not only the standard metadata fields that are interesting to us, we also have other information about documents that we need to put in there. Some of them are specific to our company, some of them are specific to Germany, so we need a couple of extensions. And of course, the important factor was that we could use these turnkey server backend implementations and didn't have to start from scratch building our document registry. So here's the architecture that we have already in place. I don't want to go into detail. That's a very complex process that leads to digitizing these documents. But the important part and where our new product steps in is when the digitization process is complete, we get a file of document metadata that it contains every information about the documents after they've been scanned. And that's basically one file per day per customer. And this file will then be forwarded to an integration engine, namely a Cloverleaf engine, which will contact a terminology service and enrich the metadata by, for example, mapping them to the IHE type and class codes and look up some other information that we want in our metadata. It will then transform these proprietary format with the enriched terminologies into FHIR resources and store them in a VONK-based backend. From there, we can now start to report, analyze. We can do our complete checks to see whether all the mandatory documents are there. We can retrieve our documents and we can export accumulated documents like whole patient records or a set of documents for another purpose. Our proof of concept, that's basically something that we could do basically 3 months after we kicked off this whole project. And since we are using a turnkey FHIR server, we didn't really have much implementation to do. We just had to get our FHIR profiles ready and start converting our proprietary data into FHIR resources and just post them onto the FHIR server. And we could, after a very short time of implementation, we already had almost 500,000 documents in our repository, and we could then start to run our first reports that would give us quantitative data about how many of these documents were originally digital documents that had been printed out, or how many were originally paper-based. We could tell what were the most commonly used document types and by number of pages. And we could even drill down onto the department level to see which department created the most paper-based records. The next steps that we are going to take is that we want to implement a rule-based engine that will run these checks that determine whether a patient record is complete. What we've done so far, and it's basically it's already finished. We are at the point where we're rolling this out to our customers, is that we created a very small piece of logic that would just gather all the documents for one specific patient, for one encounter, and then validate the bundle, the result bundle, against a bundle profile that has a couple of FHIR path expressions. And we're using these FHIR path expressions basically to check whether all the mandatory documents that we expect in these patient records are actually there or not. And then we get an operation outcomes that may include warnings or errors if there's something missing from that record. What we want to do, of course, is to make our files that are in our archive backend accessible through the FHIR registry. Because right now, of course, our FHIR server only has the document references that hold the metadata, but not the actual documents. We instead have references to a binary resource, which again does not hold the original document. It just has a few extensions that tell us where in our archive the document has been stored. And now we need to add the logic to actually go to that archive and retrieve the document to put it into the binary resource so that it can be delivered to any FHIR client in the expected format. What we also want to do in the future is to integrate more data from our customers, to not just have document metadata in our registry, but also other structured information that we would gather from other sources that would give us more context of the patient's encounter, like admission diagnosis, for example, or discharge diagnosis. We will also start to expand in not just archiving documents, but also archiving structured information, which then, of course, would also be converted into FHIR resources. There's also continuous work being done and improving the amount of information that we can extract while we are digitizing the documents, and also put them into our registry as FHIR resources with a provenance that would link the discovered diagnosis to the original document where it was found, so that we can offer additional search functionality to also search for document content. One important part of our mission has been the dealing with terminologies. In the document reference resources, we have two important parts. That is the document type, which is a precise description of what kind of document we have right there, and the generic document class. And in our instances, we have to use multiple codings because we want to use them in different contexts and different use cases. And for one, we need the what we call KDL. That's in Germany developed terminology for document types, specifically for the German realm. And our company has been working with developing this terminology, and so that is something that we would use to have an interoperable terminology that is also very granular. It has approximately 600 different codes for document types. Then we have the IHE document type. That's a specific value set from IHE Germany, which is a lot less granular, so it wouldn't be sufficient for our other use cases, but it's required for the IHE document exchange within Germany, so we have that type code as well. And we have something that is basically internal to our company that we basically use for determining the different document types per customer. So one thing that we did, and that was basically a side effect of our work, is that we had to publish this KDL terminology on behalf of the organization that developed it, and we decided that with FHIR we have now the possibility to have a machine-readable format that is also very neatly human-readable that we can use to publish this new terminology, and at the same time have it in a format that makes it usable for our project, that makes it accessible for our FHIR server. And so we helped them to publish this new terminology as a FHIR value set. And that is now available on Simplifier for anyone who would like to use it to code their document types. Of course, we also needed mappings because we are basically getting our German IHE type code from the KDL codes. So we have a concept map that is also being published with the terminology and that we in turn use to do this multiple coding. So we have both IHE requirements satisfied and our own. That's basically it. If you have any questions about what we do, please feel free to ask. If not, then I will pass on the microphone to the next speaker of this session. Oh, there's a question. Okay, yeah, go ahead.
What about image data? How do you store that?
Image data? Mm-hmm. Currently, we have no requirement at this point to do what we do with the documents with digital images. But if we had this requirement, and we are sure that it's going to come up along the road, we would basically do the very same thing, except that we would use the imaging study resource to capture all the imaging metadata instead of the document reference resource. But it would then again point to some place in our long-term archive where the actual data could be retrieved, and our FHIR server would only hold the metadata for discovery purposes, basically. Yeah.
Why are you not using the image resource now? You said that you're using a binary resource for a reference. Why not using the image resource or the one that you would use for DICOM images?
For DICOM images, we would use the imaging study resource, yeah.
Why are you not using it now too for the scanned documents?
For scanned documents? Because the document metadata is better aligned with the document reference. The imaging study is really basically hard-coded to DICOM, to mean DICOM images. It has something like, study instance, UID, modality, and stuff like that. That's not some metadata that we have available for PDFs. So that's basically the reason, yeah. Also, the imaging study would normally not reference a binary that would have just a PDF. The imaging study would usually reference a DICOM endpoint that would deliver the actual content via DICOM protocol, which is, again, a bit too much to just retrieve a simple PDF.
What about the media resource?
The media resource, I'm not sure about that. Does it even still exist in R4? I'm not sure. I think there has been a couple of back and forth about the media resource that I didn't really follow up on. Again, it's probably a good thing if you have like audio or video data that is neither a document nor a DICOM imaging. But other than that, we have no particular use case for that. All right. Thank you very much. If there are any more questions coming up later on, please just find me, tap me on the shoulder, and I will be happy to answer any questions that you have. Thank you.